In this lecture, I shall discuss model specification. A regression model may suffer from the problems of omitted variables and/or irrelevant variables. Omitted variables may inflate error term, as common variance may be attributed to the error term. Irrelevant variables may wrongly attribute common variance to them. In both these cases, estimates of coefficients are affected. Let us run our regression first. Our dependent variable is murder, and then independent variables are violent, urban, white, high school, poverty. Link test command is used to test model specification. It creates two additional variables, hat for predicted values and hat square for squared prediction. Hat should be significant since it is predicted value, and hat square should be negative since in a correctly specified model it should not have an explanatory power. Let us write our command link test. Here is the output. Now what you find is that underscore hat is significant at 1%. This is what we should expect in a correctly specified model. However, hat square is also significant, which means it also has explanatory power. So there is problem here with regard to specification of the model. Let us look at test for omitted variables. For this, we use OV test to see if our model has omitted variables. This test performs regression specification error test called RESET. Let us use this test, OV test. If the probability of F stat is significant, then it means that our model has omitted variables. Thus, there would be a need to reconsider our model. If you have seen my earlier videos, in our regression model with the same data, we found that model suffers from problems of non-normality and heteroscedasticity. Many times the solution lies in converting variables, in transforming variables. Now, if you observe our data, if you see violent, these are numbers, murder is also numbers. Now you may observe that these numbers sometimes become very small. And if we go down, you will find that now one of the states, for example, has large number of violent incidents. At the same time, the number of murders is quite large. Let us therefore transform these two variables as log variables. So we generate new variables, that is log murder equal to log murder. And similarly, let's generate log violent Now, let's use these two new variables in our regression model. They appear here. So let's say reg, and then we use log murder, log violent, urban, white, high school, and poverty. All these four variables are in percentages. Now this is our regression model. Let's use Shapiro-Wilk test to test for normality, but before that we need to predict residuals. We name it as R. Now we test for normality using Shapiro-Wilk test, and what we find is that our null hypothesis is rejected or is accepted actually, and therefore now there is normality. For heteroscedasticity test, we shall use Bruch-Pagan test, t-test. Now here also we find that our null hypothesis is accepted because p-value is greater than 0.05. So by transforming these two variables, we have been able to correct for normality as well as heteroscedasticity. Let us look at specification model and use link test. Now, our underscore hat variable should be significant, which it is. While underscore hat square should be non-significant, it should not have explanatory power, which is the case. So here, again, by converting two variables, we have been able to correctly specify our model. Let's test for omitted variables. And here also we find that there is no problem of omitted variables.